In this video, we're going to talk about the render mode property on your lights. Now, I'm going to select any one of these 5 lights you see here. We'll talk more about why I have 5 lights and what they're actually doing here in just a moment. But you can see the render mode currently set up here underneath our flare. Now, it has 3 separate settings. It has auto, important, and not important.
Right.
And
what these are going to do is they're going to actually control when these lights are going to be used in pixel shader calculations and when they won't be.
That's right, and we can see that already taking place here. You see underneath each one of these lights we get a little bit of a specular highlight, we get some evidence of bump mapping, and yet this one light sitting back here in the back gets none of that. You can't tell that there's a bump map shader just underneath him, you can't see any sort of a specular highlight, and right there we illustrate the difference between a pixel-based light and a standard vertex-based light. Now, that in itself is pretty easy to explain, and each one of these settings found under render mode allow you to determine when a light is going to be using pixel-based lighting. Is that going to be an automatic value established by Unity? Do you always want this light to be pixel-based, or do you never want this light to be pixel-based? And we could just leave it at that. Instead, though, what we're going to do is take you kind of under the hood and show you how this setting is actually coming up with each one of its values.
Right. There's a lot of different factors that play into when and when this won't. Well, we just want you to be comfortable with when this is important, when not. Important meaning this only happens in forward rendering mode.
That's right. And let's go ahead and just take some notes down. We haven't really had a chance to do this with many of our Unity videos here, but there are several factors we're going to be discussing. So first off, our render mode only relevant in terms of forward rendering.
Right. If you remember from a previous video where we were discussing our rendering paths, we had 3 different ones. We had vertex, forward, and deferred. This setting only works in forward. In vertex rendering path, we're only using vertex light, so obviously this isn't going to work. In deferred rendering, all of our lights are going to use pixel shaders if they are available.
And let's go ahead and demonstrate that real quick. If I tab back over to Unity and we jump over into our project settings and run down to the player. Now currently my rendering path is set to forward. If I set this to vertex lit, you'll notice that none of these lights are using pixel shading. If we come over to deferred, all 5 of them do. And only when we're in forward do we get this scenario where some of our lights do and some of our lights don't.
Right.
Now, that said, again, we already established that on our lights, inside the render mode setting, we have these 3 values being auto, important, and not important. Let's jot down some quick notes for those. So first, we have auto. And this allows Unity to make the decision as for whether this will be a pixel shading light or not.
Right. It will determine which lights and how many of those lights will be pixel-based as opposed to vertex-based.
Second, we have important, and this will cause a light to
always be calculated in the pixel shader calculations.
Right. Always calculated. And what we'll say for the notes, just in this case, always pixel-based, as opposed to 1, 2, and 2. 1, 2, and 3, not important.
And not important will force the lights to only be vertex-based. You'll never see them in pixel renders. Meaning, if your shader, like we have, has bump and spec, you won't notice those effects in that type of shader.
Right. Now let's jump back over to Unity for a moment, and let's take this light that I'm looking at here, which has a really brilliant specular highlight directly beneath it. And we can take our render mode and set it over to not important, and a couple of things happen. First off, the pixel-based lighting for this light disappears, but it also reappeared for this light back here in the distance. As a matter of fact, let me switch it back over just so we can see that. If I switch it to auto, we get that. If I switch it back to not important, boom, this guy in the background pops up. Now why is that?
Well, what Unity is doing is when you flag that light is not important, it goes, okay, this light will never be pixel-based. But there's a counter that says how many lights can be pixel-based in my auto calculations. So Unity is going, well, I'm allowed to have 4 currently, and we'll show you where that's set. And now that this light is no longer important, I've got 1 free light. Let me go see if there's another light out there that I can use. It finds it and then turns that light on.
That's right. Now let's take a quick look at that setting. If I go underneath Edit, jump down to our project settings, and we have a look at quality. Inside each one of our presets for our quality, we have pixel light count. This allows us to control the maximum number of pixel lights that will be used based off of the automatic render mode. So if we have all of our lights currently set to auto, this number is the largest number that can possibly be using pixel calculation. So if I jump back over to this light for just a moment, make sure it's set back over here to auto. Again, we see that 4 of these get it, and the 5th one gets kind of taken out of the mix. Now let's jump back over into our quality settings. We can take this pixel light count. If I set it to 0, we get no pixel lights.
Right. All the lights have been switched to be vertex light only.
And generally, this is what you're going to find underneath the fastest preset, just to kind of point that out. Now, as I increase this, so we set it to 1, we get 1 light. 2. 3 is kind of interesting because we did get a 3rd light. It's this guy right here, but it's really faint on the bottom. And then 4. And then, of course, if I set it's 5, all 5 of these lights are pixel based. However, if I was to create a 6th light, depending on that light's position and intensity, that light may not be or would not be pixel based.
Right. And depending, again, where it's positioned, it very well may be, and it might turn off one of our existing 5 lights.
And we'll demonstrate that here in just a second. For now, what I'm going to do, just for sake of demonstration, is set this to a value like 3. So we have 2 lights here that are very obviously pixel-based, and then there's one down here in the corner that's got just a little bit. I mean, it is set to pixel-based. It's just very faint. Now let's talk a little bit more about what is happening with our automatic setting. So I've jumped back over to this light. Currently, its render mode is set to auto, and what I'm going to do is pull it a little bit closer to the group, and notice what happens as we move it in here. Based on its proximity, Unity is changing its mind and saying, you know, this guy over here who has got a little bit of that pixel-based shading, let's go ahead and turn that off and let's give it to this light because now we've determined he is more important. If I move it away, we get a trade-off. And we could actually do it with other lights as well. So I could grab this one that's very obviously lit, pull it away, and again, we start seeing that trade-off taking place. Now, proximity is not the only determining factor here. The intensity of a light also plays very importantly into the calculation. So if I grab a light, and let's make sure it's kind of moved far away, but I take its intensity and crank it up, at some point, that intensity reaches a critical threshold and will start to pull away importance from other lights so that now it suddenly switches over and becomes pixel-based.
Right. And this all happens automatically, and if you're watching while he was dragging the sliders around, you can see that it does kind of fade in, fade out other lights, so it's not a pop. And this is a way that Unity handles things, so in your scene, it's not a drastic flickering of lights going off and other lights turning on.
Now, let's go ahead and jot down just a couple more notes here. In terms of auto, this is going to be based on the proximity of the light to other lights. It's also going to be based on the intensity of the light. And when using auto, we're going to have that cap set by our pixel light count.
And what you're going to see next is that pixel light count is a cap, but it's not a fixed cap. We can override it.
Well, all you really need to remember is that pixel light count is being used by this automatic render mode to determine our capped value. We can surpass that limit if we start setting lights to important. Because as you remember earlier, the important setting tells a light to always utilize pixel-based lighting. So let's grab a light that's already using pixel-based. Or, okay, I changed my mind. Let's grab like this guy back here who's in the dark. He's clearly not pixel-based. And I'm going to take his render mode and set it to important. He suddenly becomes pixel-based, but notice he took it away from someone else.
Right. Because right now you have a pixel count that says you can only have 3 lights that are on at any given time.
That's right, and Unity is going to try to maintain that pixel count, that pixel light count, for as long as it possibly can. Now, if we take a 4th light and we set it to important, watch what happens. All right, we take it away from somebody else. Okay, let's grab one of these lights, set it to important. Now, we have 3 lights that are using our pixel-based lighting.
Right. And according to our pixel light count, we're only allowed to have 3 pixel-based lights in our scene.
So if that pixel light count was a hard cap, we shouldn't be able to do this with any other lights, but let's go ahead and select one and switch this over to important, and now we have a 4th. We can even select our 5th light, and now we have a 5th. So by setting lights to important, you can surpass that pixel light amount. Again, that number is a cap for those automatic calculations being used in the auto mode. Now, all of that said, I do want to mention that obviously pixel-based lighting is going to be significantly more expensive than vertex lighting, and so this is not the kind of thing you really want to do to every single light in your scene if you're using the forward render path.
Right, hence the name of it being important. You only want to use it on important lights.
Right, things like a character's flashlight, the headlights of a car. You know, if your hero is carrying a torch, you know, you may want to set that to an important light, perhaps the sun,
the moon if it's night.
Right.
Just things that you always want to have on and would look kind of odd if they were turned off for some reason.
And if it's absolutely critical that all of your lights have that kind of calculation, you're really going to want to try, consider looking at the deferred render path, which is, of course, a pro-only feature and not supported on every single platform out there.
Right.
Now, that is a really good job of explaining how this render mode setting works, but there's one more factor I want to throw out there without branching too far away.
Right. We mentioned that these are pixel-based lights, which means they require a pixel-based shader to work on.
That's right, and currently we're using bumped specular, which is pixel-based. That gives us the bump mapping and the specular highlight. But if we were to take this all the way down to diffuse fast, this is a vertex shader. This is not going to get, it's not even going to utilize any pixel-based lighting whatsoever, and so it doesn't matter what our lights are set to.
Right, even though our scene is still being using the forward rendering path. The fact that we're using a material that is using a vertex shader means it's going to ignore all pixel-based lighting altogether.
Right, and I didn't want to branch too far away from the topic of lighting, but it's all very interrelated. You know, your shaders really control how light interacts with your surface anyway, so I did want to mention that. All of these settings we're talking about in terms of your render mode, they're relevant for forward lighting, sure, but they're also going to be controlled by what kind of shader you're illuminating in the first place. So that's a rundown of the render mode property. Again, very simple on the surface. If you just want to keep it simple in your head, you can just say, this controls whether or not a light is going to make those pixel-based calculations. Will it always do it? Will it never do it? Or is Unity going to make an educated decision based on proximity and intensity? But I think we've done a pretty good job of showing you all of the factors that it's dependent on and ways that you can help control that. That is going to wrap things up for this video. Thanks for watching.